So I'm Karthik Sudo. So today topic is play with Tangram. So we just introduce about the Tangram and then topic of some interesting topic related to Tangrams. So we can see. Uh, so first of all, Tangram. Tangram is a it's uh, invented in China 200 years ago. This is a square pieces. The square can cut into seven equal pieces, not in equal, but some kind of pieces. Then, based on that pieces, we can create several figures, such as shark, bears. There are more than 6,500 pieces we can create. So some kind of geometrical shapes can create, and some proofs can done through the tangrams. So today, uh, 1 minute, it's a square. Can you think of this square can create it into rectangle? Any thinking? This is a square. So this square can modified into rectangle. Some little bit changes needed. Okay. So we can see. So these two pieces come here. So it make it as a rectangle. So the square is transformed into rectangle. So this thing from our mind thought. So that's a mathematization. We just think a mathematization. So just alternate the two pieces into varieties of position. We get a rectangle. So next, can you try to make it as a triangle? Yeah. So the same seven pieces, one, two, three, four, five, six, seven pieces. Totally seven pieces. Here also seven pieces. So here also seven pieces. One, two, three, four, five, six, seven pieces. So all of the seven pieces, but the change the position makes into the different varieties of geometrical figure like square, rectangle, triangle, and rhombus also we can get, and parallelogram is also get. So different types of polygons we can get based on the same seven pieces, just to modified, and we can get varieties of polygons. Like this is a triangle, so this is a right angle triangle we can get, and square also get, and one, two, three, for quadrilateral we just arrived, and this is one side trapezium, one side trapezium we just get, and then this is also rectangle, and one, two, three, four, five. So five gun or pentagon we just get. So similarly, we can get varieties of geometrical figure. Based on the varieties of geometrical figure, one can play with these tangrams. Basically, to create this kind of geometrical figure is a challenging one. Um, if we see, then only we just fix into the polygons. If we are not first time see, to create is little bit challenge. Okay, so this needs more visualization needed. So today morning, Professor Sarang sir explained about a cake cutting problem through the cake cutting problems. So this takes so much proofs like that. We just visualize and based on some kind of hypothesis. So the question is: a square cake cut into seven equal parts of triangles? This is the questions. So this is the questions, and Sarang sir proof is based on two theorems. Okay, so now we can try to visualize using the tangrams idea. Okay, so let's visualize the tangram. So this is the tangram. This is a small piece of tangram, small triangle, and this square can cut into two equal parts of small triangles, and this parallelogram is also make it as two part of a small triangle. And this is also medium-sized triangle. This medium-sized triangle can cut into small triangles. And this is biggest, not biggest, it's a right angle large triangle. So this triangle can cut into, for example, if we see now, so like that. 1, 2, 3, 4, 5. So here we just totally 16 pieces. This is one first piece, and third, 4, 5, 6, 5, 6, 7, 8, 9, 10, 11, 12, 13. So similarly, 14, 15, 16, so 17, 18 pieces. So we just plate into the 7 equal members. So first triangle. So this triangle go to this plate, and so another small triangle. This part go to the second plate. So this is also done. And the third thing, the parallelogram part. So parallelogram first part is also done here, and the parallelogram second part is also done here. So totally we used the parallelogram also. Third thing, the medium sized. This is the medium sized triangle. So this medium sized triangle utilized in the fifth member. So as a medium sized triangle 1, and here also medium sized triangle part. So I just trying to equalize the triangle. I just split the square part, square brownie cake, cut into 7 equal part of triangle. I just try to make, but it is not possible. We can visualize, right? So almost this medium sized triangle is also over. Now it's a square. Square is also there. This square, the first part of square done, and the second part of square is also done. That means this 7 come here, this 8 part, the 6 part is come here. So this is also the square for first part. So here also one kind of triangle. Okay, so this is also done. Now the biggest. Now this is the big or largest. We can assume large triangle. So this large triangle has a 1, 2, 3, 4, 5, 6 pieces totally. So these pieces can divided here like isosceles part 1. So isosceles part 2, and this is also isosceles part 3, isosceles triangle part 3, isosceles triangle part 4. This is also done. So then this is also done. The final part of this triangle, we have to split into the triangle. So now I just trying to split into the triangle. So this is second part of isosceles triangle part 1, second part of isosceles triangle part 2, and 3 also done, isosceles triangle part 3. Now remaining this part square is have to split into 7 equal parts. Now everybody has equal part of triangle. If we have to cut into the square in as 7 pieces, 1, 2, 3, 4, 5, 6, 7 pieces, then this, if we attach this small strip into this part now, this is not leads to be a triangle. So our question, a square cake, square brownie cake cannot cut into 7 equal parts of triangle. If we want to make a cut into 7 equal part of triangle, then it is not lead to be a triangle. it might need to be a quadrilateral. So that's why the proof is mathematically, but we can visualize using the tangrams. So that's all. So tangrams has varieties of interesting puzzles is also there. You can visit this website and play with tangrams. This is the interesting book. So based on this interesting book, there are more than 330 puzzles is also there. You can try it. Basically, this kind of tangrams visualize the mathematizations. So that is my end quote. So if we want to strengthen our body, we can eat food large. But if we want to think more, what we can do? So do the mathematization. For that mathematization, these kind of tangrams stimulate our mind to think large. So that's my end quote. Any questions? Yeah. Yeah. Yes. So it's a nice questions. So what is the interested to involve this kind of tangram kind of things? Yeah. So my questions now. So after my complete my UG graduate, so one questions. This is given. This pieces is given. I want to make it as a reconstruct into a square. That is biggest challenge for me. Even the small things cannot do. It takes more than half an hour, more than 1 hour needs. It's a dissection and make into whole thing. It needs large number of time. After that, I just realize what are there in this tangram, and we make into the rectangle. Now that is also takes more time. So after that, burdens, there are a lot of things is there. That's why I really enjoy this kind of things, tangrams, and also apply this kind of things into primary school standard also. Anything, questions? This is visualization part. Mathematics proofs can visualize in varieties of manner. This is one kind. So nothing.
Questions?
No, nothing. I think.
Sir,
Yeah.
yeah, I mean, did you like mean through tangrams we can divide a polygon into equal parts?
Uh,
Like at the end, you were saying something. I was like trying to make it proper, but I'm like, can we do it or not? Like,
Actually, it's a hypothesis, but here
okay,
the that statement Montcosy's theorem, na. So a
uh-huh.
square cannot um, cut
We divide
into
into odd numbers.
odd numbers. That's his statement. We can visualize whether it is workout or not. So this is kind of thing to visualize. That's the thing. It
Oh,
is a hypothetical statement.
mm-hmm. Okay, okay. Thank you, sir.
Thank you.